What's up? For this experiment, I will discuss the three basic logic gates: the NOT, the OR, and the AND logic gate. So what is a logic gate? A logic gate is a basic building block of a digital circuit that has two inputs and one output. The relationship between the input and the output is based on a certain logic. The basic logic gates are categorized into 7: AND, OR, NOT, SOR, and AND, NOR, and XNOR. For this experiment, we will only tackle 3 of the 7 gates. These are the AND gate, OR gate, and the NOT gate. The materials needed are the 7404 hex inverter gate, 7408 AND gate, 7432 OR gate, 7411 triple input AND gate, an LED, a 360 ohm resistor, breadboard, long nose pliers, connecting wires, and a 5-volt power supply. Before starting the experiment, we must use a safety goggles. Single inverter circuit. For the first part, we will follow this diagram to construct the circuit for the NOT gate. The NOT gate is a digital logic gate with one input and one output that operates an inverter operation of the input. Terminal A is at logic 0. The output is 1. And if terminal A is at logic 1, the output is 0. The output of the NOT gate will be the opposite or the counterpart of the input. That's why it is called NOT. Examining the basic operations of OR gate using 74LS32N. For the next part, we will follow this diagram to construct the circuit for the OR gate. If both terminals A and B are in logic 0, the output is 0. If the input terminal A is at 0 and input terminal B is at 1, the output will be 1. If the input terminal A is at 1 and input terminal B is at 0, the output will be 1. If both input terminals A and B are at 1, the output will be 1. The output of an OR gate is true only when one or more inputs are true. If all the output is false or 0, the output will be false. Examining the basic operation of 7408 AND gate. For the third part, we will follow this diagram to construct the circuit for the AND gate. If both terminals A and B are at 0, the output will be 0. If input A is at 0 and input B is at 1, the output will be 0. If input A is 1 and input B is 0, the output will be 0. If both terminals A and B are at 1, the output will be 1. The AND gate is a digital logic gate which gives an output of true only if all the inputs are true. Multiple input AND gate using 74LS11D. For the fourth part, we will follow this diagram to construct the circuit for the multiple input AND gate. If all terminals are at 0, the output will become 0. Terminal C is at 1, the rest terminals are at 0. The output will become 0. If terminal B is at 1 and the rest are at 0, the output will become 0. If all of the terminals are at 0 except terminal A, the output will become 0. The output will only become 1 if all the terminals are at 1. The multiple input AND gate is still an AND gate. It will still give an output of 0 almost every time unless all inputs are 1. We will now try combining the three logic gates. For the first part, we will follow the diagram to construct the circuit for the AND or combination circuit. Part 5 of the experiment: Combinational Logic Circuit. Combination of 7408 and 7432. Input A is 0, input B is 0, input C is 0. The output will be 0. Inputs A and B are 0, C is 1, and the output will be 0. Terminal inputs A and C are 0, B is 1, and the output is still 0. Both terminal inputs B and C are 1, and A is 0. The output will be 1. Terminal A is the only one that is 1. The output will be 1. If terminal A and C are both 1, the output will be 1. Only terminal C is 0. The output will still be 1. If all terminals are 1, the output will be 1. Output will be 1 if the inputs in 7408 IC are 1 and at least one input in 7432 IC is 1, because 7408 is an AND and 7432 is an OR gate. The last combination of the basic logic gates, the AND or NOT combination circuit. As part of combination of logic gates, we will combine the three basic logic gates and follow this diagram to construct the circuit for the AND or NOT combination circuit. In this combination circuit, the output will only be 1 based on the following. If all input is 0, if only the D input is 1, if only the C input is 1, if only A input is 0, if only B input is 0, and if all inputs are 1. At ayun, that was the three basic logic gates, the NOT, the OR, and the AND gate. Quick recap muna tayo. The output of the NOT gate will be the opposite of its input. For the OR gate naman, the output of the OR gate is true only when one or more inputs are true. Then lastly, for the AND gate, it will only have an output of true or 1 if there are no input of 0.